Okay, finally we're going to run naive Bayes using our caret library. So which means we have to first set up a train control. We'll call it trctrl. Then we can specify a method for sampling. Okay, we will just use method equal to none. Okay. And then we use say NBCR for caret, right? And we do train, and within train the first item is the y variable, or that's your target. So the target is in train. Okay, so all the rows, and the last one, okay, train has, there are 6 variables. The last one is the target, the 6th variable. So we'll call that train. Here it should be train.df. Train.df, all rows, column 6. And then x is equal to the same train.df, all rows, okay, and columns, all columns except 6. 6 is target, so everything else should be included as predictors. And then you have to specify the method. Method equal to NB for naive Bayes, and that's it. Okay, so now we run these 2 lines of code, and we have generated the output. Now we need to do prediction. So if you want pred probability using caret, so then use predict NBCR. So from the model information that's saved here, and then you give new data to be valid.df, and then we say type equal to, so in caret you have to use prob. Okay, remember previously we used raw when we used E1071, right? That gave us probability, but in caret we use prob. Okay, and then run that, then you get the probabilities. And for predict membership, the type should be class, or you can leave it. That's the default, so you don't have to specify. Don't specify type, and you will get, so predict class CR, and then don't specify anything for type. Okay, and you run that. Then see, if you look at pred class CR, okay, pred class CR is right here. So if you want to look at pred class CR, so uppercase V view, right? And say pred class CR. So now you see the predictions. Now once you have the probabilities and the predicted class, you can always run gain and then generate your lift chart. Okay, now let's instead of doing the gain and lift charts, we've already done that using the E1071. Let's run ROC curve. Okay, let's generate an ROC curve, which means we have to set up library PROC, once we have that, so we run that, and once we have that, then we can do R ROC, right? Then we need to specify the actual class, so that will be valid df flight status. Okay, so that's the first item, and then we need to specify the probability, right? Probability will be in pred prob cr, and we want the probability for delayed, right? And then we need to do plot equal to true, because that will generate the plot for us. Okay, but we need, so that will generate the plot for us, but we need to add some more details. Okay, so let's so for pty equal to small. If we run that, then it'll be more compact. Okay, and more fuller ROC curve code, I'm going to copy paste from the previous chapter. Okay, so we'll change the color to blue, line width to 3%, to true, so these numbers will be converted to percent. Legacy access, so it'll be 1 minus specificity, and then we will print the area under the curve at 40 and 20. Okay, so let's run that, and there you have it.